Hello, I'm Tom Wallace with Emerson. Welcome to this short introduction on some of the ways Emerson is using FDT DTM technology to improve productivity, reduce errors, and give a better end-user experience. We'll be demonstrating using FDT Container. We'll be demonstrating on the Rosemont 848 multi-point field bus temperature transmitter. I'm just going to point out a few things on the screen before we get started with the demonstration. The first is you can see the device status. The device here is good. The second thing that you can see is mode. Foundation field bus devices have modes, and the mode of all the blocks in this device are in service. Next, you can see the primary purpose variables. Now, here's something interesting. With most field bus devices, you can only see one process variable per block. So if you wanted to see, for example, 8 different variables, you'd have to look in 8 different blocks. With the 848T, we've actually given you all 8 of these process variables and their status on a single screen. The last thing we want to point out is some shortcut buttons to frequently perform device operations. Now, to start this demonstration, we're going to cause a sensor failure. We're actually going to disconnect one of the sensor leads. You can see that sensor 1 is now showing as bad. You can see in status that the device shows a failure. Inside status is a troubleshooting button. Clicking that button will bring us directly to a troubleshooting screen. As you can see, you get both recommended actions for correcting the problem and also a picture of what the error might be and where it might be located. For example, it might be the wiring to the transmitter itself that's shown here. It may also be the sensor. The failure is clearly described. Sensor number 1 is open. There are several recommended actions. The first one is to check the sensor configuration. This is frequently done first, as this can be done without having to go into the field. A shortcut button is provided to bring you directly to the sensor configuration screen. The next recommended action is to check the sensor wiring. The final recommended action is to check the sensor itself to see if it's failed. Now, we're going to take just a minute and we're going to reconnect the sensor, fixing the problem. Hold on. I've reconnected the sensor lead, and now you can see the device status is good, and the sensor itself is also good. Now I'm going to close the diagnostic window and move on to adding a new sensor to the device. As you can see, there are a number of sensors that are not used. What I'm going to do is add another sensor to sensor position number 7. I'm going to do this from the Configure Sensors screen. The first thing the screen does is ask me what sensor I want to configure. From a single screen, I can actually configure any or all of the sensors at one time. I've selected sensor number 7. The sensor configuration procedure is pretty much automatic. The first thing it does is tell me that if I'm going to be configuring a sensor, it's going to be taken out of service. I click Next and proceed to the next step. Next, I need to select the sensor type. Currently, there's no sensor here, so it's not used. I get a drop-down menu that shows all the sensor and connection options. I select the appropriate sensor type and connections, and then I hit Enter to save this choice. Next, I'm given the option of configuring units. I'm going to accept the default units, so I'm going to click No. There are advanced configuration options we could perform, but they're not needed here, so we're going to finish sensor setup. This new sensor is configured. We can set up additional sensors or exit. And configuration is done. And that's it. You've seen a brief overview of this screen. You've seen troubleshooting and repair, and you've seen adding a new sensor to an existing device. This is Tom Wallace. Thank you for watching. Have a good day.